All right, so the next problem that I'm going to work through is it's question number 8, or it's similar to question number 8. You've got something a little bit different. This question reads, you have a volume of a buffer, and for me it is 500 milliliters of a buffer with a concentration of, it would be 0.130 molar. And then you have 605 milliliters of a weak acid with a concentration of 0.200 molar. And this weak acid has a Ka of 3.87 times 10 to the negative fifth. Now what I always like to do is whenever I have a Ka, I might as well just go ahead and solve the pKa. And whenever I plug this into the calculator, I find that the pKa is 4.41. Remember, this is just negative log of 3.87 times 10 to the negative fifth. And that's equal to 4.41. Okay, now that's just something I get out of the way, because otherwise it might be something that is, it's going to be relevant to the problem. Okay, now this question goes on to say, what is the pH of this resulting solution? So what I'm going to do is I'm going to set up my problem. HA plus OH minus yields A minus plus H2O. Now, initially what I've got is 0.121 moles of HA, and I also have 0.065 moles of OH. So I know that this hydroxide is going to react completely 0.065 moles with my HA. On the other side of my equation, I don't care about water, but I can also say that this is going to be plus 0.065 moles. This is going to be minus my change, my initial change and final. My change is going to be minus 0.065 because that hydroxide is going to react with my HA. Now, the next thing that I'm going to do is put my final concentration of hydroxide at 0, the A at 0.065 moles, and then the HA is going to be 0.056 moles. Okay, now this question though is asking me what is the pH. In order to solve this, I need to know my Henderson-Hasselbalch equation, which is pH equals pKa plus log of the concentration of A over the concentration of HA. Now, pKa is 4.41. The log of A, well, this actually, I need to remember, do a concentration calculation. I have the number of moles. This is 0.065 moles, but what's my concentration? Well, my volume is the combination of 605 mils plus 500 mils, so 1.105 liters. So this is going to be 0.065 moles divided by 1.105 is 0.059 molar. So that's A. So I'm going to plug in 0.059, close the parentheses off, and then divide this by, well, this number, 0.056, divided by 1.105, that is going to be equal to 0.051. And so, whenever I plug all this in, I come to the conclusion that this is 4.41 plus 0.06, because the log of 0.059 divided by 0.051 is 0.06. So my answer is 4.47. All right, hope that was helpful.